you want me to?
Yeah, you want to start with the...
Okay. I'm going to do it too.
Sure.
See what I come up with.
Okay.
Since I'm here, I'm really curious. Okay.
Start.
I need to. Oops, I'm done with here. And I want to be here.
So,
On stage. Winter 2020 Katas. Okay, so let's see here. I need to
Yeah,
create
don't
a new
forget
Kata project.
we're putting in the duration, not the end time.
And this is going to be lags.
Because we're gonna have to calculate the end time. So I still want to. No, I still want to use that.
yeah, you want
Yeah, still use the end time is what we're gonna save, but we're gonna give it the duration. No, I don't think we even need to save the duration
Me.
because nothing on here has like.
okay, so just
yeah.
start and right?
No. We're gonna need to put the duration in there, but when the end time, we're gonna calculate using the duration.
Katas.
You know what I mean? So when we set the end
okay,
time.
so you want duration.
No. I want duration as part of the constructor. But we don't need to save the actual duration because we can always calculate that back if we need to. What we really care about is the start and end time.
So I need to add all this stuff.
Yeah, so leave it just like it is now, and then add duration there. Yeah, cool. So then inside the constructor, we need to set the start time. Yeah. So it's the start, and then this dot end is going to be equal to what? Start plus duration.
Okay.
Yeah. Yeah, I like that. And price.
Okay, so that's
Yeah. So now we have
Okay.
a flight.
Got all that. So let's see here. Now let's rename things.
Yeah.
And let's call this
so
flags. Yes, change those to.
Alright. So yeah, it's gonna have.
Do
no,
that to.
oh not no, the next one.
We'll just
right
make sure that we got.
No.
Oh well, actually, if we just do. See, that's where it's
R plus
complicated.
X, maybe
Um,
W.
So we're gonna have pointers to the left and right for the in the not in the node, right? In the node.
Yeah, well, we need to have a variable amount of children. Like we can't just have two, because in our example right now, we only have two possibilities.
Okay.
But if we had different numbers, there might be 3 or 4 flights that come after.
Yeah, I mean the children is like 0 or more.
Yeah, so we
right?
really need like a
Yeah.
vector
An
that we
array?
can add to.
Oh.
Because, well, we could use an array, but we want it to be more dynamic, I assume. Because we don't know
Well, what's a Java collection that gives you a dynamic array?
the vector.
In 1998, yeah, it was a newer one. Array list.
Oh, okay, yeah. Yeah, you're right. I don't use Java much.
What you been doing this term?
Learning how to use Java.
There you go. Right on.
I'm actually getting a lot better at it now.
Excellent.
But I'm used to C++ and vectors are still pretty
Yeah,
popular.
me too.
I apologize.
No, I'm really
I feel your
enjoying Java.
pain. Good. Okay, legs.
I'm still getting used to all of these exceptions.
Yep. That's part of it. Okay. So let's see here. So
Yeah.
legs test. Okay.
That's it. And then which is gonna have.
Well, let's just see here. Example from Kata.
Yeah, so
Let's see what this is.
the original node is going to have, well, you're going to give it a
So
flight.
there's flight that has
So
a
the first node, we're going to pass in a flight,
name.
which would be whichever flight we're comparing all the
Okay,
ones to.
so let's see here.
Now, one thing I am thinking is,
Legs.
so our biggest problem right now is if we have one level flight, so that's our first node, and then we're going to have an array list of all the other flights. Now, if flight 3 has, flight 5 come after it, we need to be able to do a third level, so it would basically be like an array list of our array list nodes. In fact, actually, we don't want to do an array list of flights, we want to do an array list of nodes, because all of the other flights are gonna, well, actually, you know what, you're right. So that's the thing I'm trying to say now, is if we did an array list of nodes, we could do the flight 3 node, which, let's say we make the flight 3 node with 3, it has an array list node of flight 5. So we could probably make it so that, you know, it only has one level, and then we grab this one, and if that has any children, then we can calculate this one, and that one. You know what I mean? Because I'm thinking, I don't know how we would do like a second level of nodes, like if you were to do 3 flights in a row, other than being able to grab their children. Because if flight 3 is a child of flight 1 and flight 5 is a child of flight 3, then we know flight 1, flight 3, and flight 5 will work in combination. And that would work for any number, because, you know, flight 5 could have flight 7 underneath it. So if we made it an array of nodes, then each of those nodes would have an array of nodes. And we could just cycle through all of those possibilities. But I'm not sure how we would call that.
Equal to, what's the answer, 18 or something? Yeah, 18.
Using a loop, I guess.
Yeah, does it say anything in the Kata that like limits the amount of things we're gonna get? Like how many flights can stack on top of each other? Do we even need to worry
I don't
about
think
that?
so.
Yeah. It would be nice if we knew that, you know, maximum of 2 flights could go or something.
No, I think that's the whole idea. I mean, if you have enough flights, you're going to have as many hops as you want.
Yeah.
I suppose you're kind of, actually, well, you're not certain, maybe you're kind of limited by, like, do you have a start time greater than 23 or something, but yeah, who cares? I don't think that's the idea. Okay.
Yeah, so we need to build a tree.
So let's see here. Obviously, this is going to fail.
Okay, so 3 class,
So, watch it fail.
which is gonna have a node.
Watch it pass. Super lame.
Yeah, no, I haven't had to do this organically in a while.
So let's see here. So we're gonna look at the flights. So let's see here.
So tree has a node.
Yeah, so the tree has a root node.
Yeah.
Yeah. And then it's got, that root node has a,
Wide or branches, I guess.
yeah,
All flights. I want this to be a sorted set.
which could also be root nodes. So,
Sorted set. Flight of names.
Do you think we should use the array list here also?
yeah, but I don't want just an array list. Like, it's like, yeah, I guess it would be an array list of nodes, and then each of those would have an array list of nodes. So,
I don't even need to store the name. Who cares? That'll be interesting.
I think if we did the first thing we were gonna do with loops, that would be so much easier.
yeah.
Where are you
I
looping
think
over
if we
though?
can combine the two. Well, and that was the issue we were having, was trying to figure out exactly how many loops we'd need and where we'd stop. Because yeah, if you built enough of them, we could calculate every combination brute force style.
No, I think you want to. You're getting build a tree and traverse it.
Yeah, we're not comfortable with the ability to build a tree. So I'm gonna brush up on that quick.
Well, I think in this case you need to build the tree yourself.
So we need to have functions that add flight or
Mm-hmm. I think so. That's what I'm doing anyway. Oops, that's not right. I want to hash set.
Yeah, but we need to be able. So if we have a tree, we build a node and we make that our root node, and then that node is going to have child nodes, right? like, how would we represent the child nodes? Like, would you just use some kind of array list with other nodes?
Okay, what if we choose the highest price of those child nodes and then proceed from there?
Like the best combination of the child nodes? And then, because
I know it's not gonna be.
yeah,
It's not gonna be the best because maybe the third.
maybe the first three, even
The
though
third level
the
is gonna
be
have
more than yeah, which is we
Yeah, you
definitely
have
don't
to.
wanna
Yeah.
do that.
Oh, I think there's like a comparators thing.
Hmm. So if we do
There.
okay, so a node will have an array list of nodes, and then each of those nodes will have an array list of nodes, so that each of them, so that's our tree. Yeah, so if we hold our node here, and we have our array list of nodes, each of these are gonna have an array list. So that's more than fine for our tree. So basically we'll go through and this would be our flight 1, be our first node, and we'll go through and add all the other flights that are capable of it. And then we'll go through to each one of those and add every flight that's capable.
How are you going to go up after on? So with the index, right? You're gonna loop through it.
Yeah, so it would be a loop, like you take the, so if we did like our flights, and we probably have an array of them. If we cycled through,
So let's see here.
we just took the first one, so we took flight 1, and then we took flight 2.
Okay, so we have an array of flights.
So we need to
with the
modify.
flights that can.
Yeah, so this would be our array.
So those flights are going to be stored here.
Yeah, and then we'll go through for each of them. So we'll loop all of these flights.
Okay,
So for the first one, we'll take flight 1, and
so say index 0 is going to be flight 1.
yeah, so this would be
Or flight 3.
this would be 0. So flight 1 would be index 0.
Okay.
We do that.
And then index 0 of flight.
Well, if we did a second loop inside that, so for flight 1, we'd go through the rest of the array, and then so flight 2, can we add it to a child of flight 1 by comparing the start time to the end time? If not, then we won't. So for flight 3, we can, and then for flight 4, we can. And then we go to the next one, we go to flight 2. Can we add then we start at the beginning again, so can we add flight 1 to, well no, we wouldn't need to because, yeah, we wouldn't need to go backwards because flight 2, yeah, because
You're already going to have the variable that's going to start.
yeah,
Already stored previously.
so the only, so if we sorted them like you said originally from start time and went through them, we wouldn't have to go backwards because there'd be no way a flight that started after a previous flight could be connected to that one. So yeah, just like you said before, we should definitely sort them. So if we sort based on start time, then we can do flight 1, flight 2 doesn't go, flight 3, flight 4 do, then flight 2 would be the next one, and like I guess we could do it again with flight 3 just to keep the loops going, but after that, I guess because this wouldn't have anything, flight 4 wouldn't have anything, but they'd already be done anyway.
Final route.
But if we did it like this, we would have, 4 root nodes basically, and let's say that this one did have a flight 5, like flight 5 wasn't there, and this one would also have flight 5. So after we set up all these trees, if we went back through, we could figure out how to call, like go through this one, go to this one, and then call that guy in order to find out this one.
Yeah.
Like that would be our.
But this is really too complicated.
Well, I definitely think this is a little bit more feasible. Like I think that this is the implementation of what we got going on over there. So let's try to put this nested loop together for these nodes and build these tree structures for each of the flights, and go from there.
Actually, I don't want to.
So where are these nested loops?
So each.
The tree.
Yeah. Well, do we need a tree? Yeah. So we don't need a tree and a node class because the tree is going to have nodes in it. So let's use the tree class, but we'll get rid of the node class and move what we have in the node class to a tree class.
So are we gonna have an array of nodes? We're gonna have an array of nodes.
Nodes, yeah. Well, yeah. So I guess we do need the node class. My bad. Yeah. Okay. So yeah, let's keep the node class. So I think that's the easiest. We have an array of nodes because each node at that point will have an array of nodes. Wait. Is that
Each
right?
node is gonna have an array of the.
Of other nodes. Yeah, because that way we can connect these ones. So like flight 1 will have a node to flight 3, and then flight 3's node
Subset.
will have. So can we use? Yeah, Java doesn't have pointers. Basically, if we could figure out how to put this node into this spot, and then also have its because the flight 3 is going to have a node, and it's going to have its children nodes, and those are only flights that come after flight 3 because they're all sorted by start time. So we never have to worry about flight 1 being a child of flight 3, right? So if we put flight's 3 node into flight's 1 node array, then we have all of the flights that flight 3 is connected to. And we have the ability to expand more than just 2 flights.
Okay, first we need to identify the node.
How do we
flights.
call? So that's what we need to do is make like each flight needs to be a node with its connecting flights as nodes, and then we need to be able to link them all together. How do you do that? It's like we were using pointers, and you just do a reference to each one. So let's look at our classes real quick. So the tree, yeah, go to the node class real quick. So a node has a flight, and then it has a list of flights.
price of each one.
Yeah, so, yeah, that was the original idea, was to just loop through, like start with one flight, compare it to every other flight.
So you don't have to have 3 branches or 2 branches for an airline. You just go through one and then start originally.
With the next airline?
Yeah.
Or the next flight, and then do every one after that.
Yeah.
Because, yeah, you're right, because now that we realize that you never have to go backwards,
So you just have to compare each income or price that you stored for each path. So maybe save the flights, and then just so save the path.
Yeah. It's confusing.
So if we use but how do we know that? Yeah, this is confusing because however, is there a way that we can go through this first? Go through flight 1, 2, 5, and then calculate the price,
Yeah.
and then store it in an array.
Well,
So
yeah.
index 0 is going to be the price of this path. And then we're done with this path, which is index 0. So go this path,
Go to the next
and then store the price. And then go to the second path. If it has more children, like here,
Yeah.
then go there, calculate this, and then go there, calculate this, and then so
Yeah, that actually, no, that makes sense, because if we did
and then
that,
just compare the price and then know the index of the path that you want to take, and then from there take the second, for instance, second index, and then
yeah, it would just be a matter of like how, because I figure for like, you'll need one loop here to get you to here. Because then if you loop through here, you can go through one level deep, then you need another loop to get this deep. So like how many hard-coded loops are we gonna, like how deep are we gonna go is the problem. Because there's no way that I can think other than recursion to go through like a variable amount of loops.
first I want to know how are we going to start this?
Well, this particular way, we wouldn't really need to store anything other than a global max variable with an array
So you're just
of flights to get there. So this is the
so
original
the
idea.
flight
that we
is going
had.
to be an array. Flight is going to have array, and then the branches are going to be what? An array, right?
Yeah, so each one of these would have an array.
And each one of these is going to have an array.
Yeah, which is, we're back to our node thing. So each one is a node of other nodes that have other nodes.
Okay, so at the end, we need to know how many flights. We need to ask the airline how many flights are there, so that we know how many. We save it as n. The
Yeah,
number
I don't know if we can. Well, I guess we can do that. Yeah, because if we knew how big our flight array was, because I assume we're getting an array of flights originally.
So make the loop with I less than n, and loop through the first index. That's a loop, I mean. The first index for all, and then calculate the first index if there's an index in the second array.
Yeah, so
So if say this is 0, index 0 of the outer loop, then go through any
one
possible
through
ends,
n of the rest
yeah,
of them, yeah.
the possibilities, and then proceed. So first proceed for the
Yeah, but in order to for every check you have,
we can count the number of indexes that have flights for each time. Count the number of so count the number of indexes that exist in the array.
Okay, so like how many are in this array?
So yeah, if there's 3, then just loop for n, which is the count, whatever the variable
Yeah.
that counts,
Yeah,
and then do this every time until.
yeah. I'm trying to figure out because you would use one loop to get here, then you need another loop to get here, and I understand being able to limit how many times you loop, but how do we make the amount of loops variable? Yeah, and what I guess what you could do is like set the amount.
Do this with do while. Do while this index is doesn't matter right now. Yeah, right. How do we make the loop as much as the branches are?
Yeah, and that's what I'm saying. So like we
Do
can,
we need a for loop? Maybe not a for loop. Maybe just a while loop, but then cited.
but
I don't remember.
yeah, and if a while loop would be if we got into recursion. So like we would call this, and then call this one, and then we do a loop on this guy that would call each successive one. So we would know that like if this was 3 and there's 5 altogether, you'd know there'd only be a possible of 2 more after it. So that's something, but I feel like we're going in circles at this point.
I think, yeah. There's no restriction or no.
Yeah, and that's why I feel like if we had, I'm gonna get rid of all this for now. So I like this idea of a node being a flight with an array of nodes. Because that way we could have flight 1 with its array of nodes, which we could have flight 3 and flight 4 for. And then, we'd have flight 2. So we basically have like mini trees. Then you could do flight 3. So if we build a tree for each one, and then say there was a flight 5, we could go through afterwards. If we had all these trees built up, then we could go through, we could go with 1, then we could, go over and reference, because we'd go through F1, we'd grab its first array, the first node in its array, and then if we could use that to go and find this one, then we could use the start here to go to this array, and if we did that, we could go to, flight
Oh, that's nice.
5, if that was a possibility, flight 7. So if we had, because it would be pretty easy, I think, to build these little mini trees, because it would just be flight 1, everything that could go with flight 1, flight 2, everything that could go with flight 2, flight 3, and everything, and then at that point, so flight 3, yeah, that would be easy actually. So what you do is you find flight 1. After we had all of these, you'd start with pretty much one loop, and flight 1 you'd go through its children, and then you'd go through its children. So it would be flight 1 dot flight array and flight array 0 would be F3, and then flight array 0's flight array
Yeah, so the path,
0, and then the cost of that would equal to max, which would be this little max variable. And as this max got higher and higher on this, we'd be able to save that chain of events. Does that make sense?
I mean, kind of.
Yeah. Because I feel like that's the same thing as building.
Sorry.
I feel like it's the same thing as having a multi-layer tree, basically. I'm just trying to figure out. Okay, well, the biggest thing that we have going for us is the flights are in order. So we know that. At least this is an assumption we can work with. that if we put them in order, then we don't have to worry about them ever going backwards. So if we start with a set of all of our flights, which we can add all of the flights into a set from the array, or we just
Just ask the user for the set of flights and then store them
all right. So yeah, if we had an array of flights,
so array of flights.
so yeah, so what I'm thinking is we take like the first flight, flight 1, and then flight 2 doesn't go, so you leave it. Flight 3 does. So you go back up to your array of flights and get rid of flight 3. So right now, like flights 1, 2, 3, 4, 5 or something. So flight 1 we've already done, so we take that out of our array. Flight 2 we haven't, so we leave it. Flight 3 we would, so that would get rid of it. And then flight 4.
So make a temporary copy of the array.
Yeah, something that we could work with. Yeah.
Okay, this is kind of easier.
Yeah, so this actually I think makes a lot more sense because we can use the fact that we never have to go backwards.
So just to understand, you're gonna ask the user for the flights, input the flights so as an array of array, which is the array of
No, because they're gonna give us the
the price of the start and the duration, right? They're gonna give it the
so we're gonna get an array of flights, and each flight has
already has those. Okay,
Yeah.
so an array of flights, and then you're gonna just check the index 0 at first.
Yeah, so index 0 would be flight 1.
No,
And then-
because I
And
Just
then
subtract it
yeah,
or
so
remove it.
so we take index 0, remove it from our list, and
What
add
if
it to our
index
tree.
0? Okay, so index 0 is always going to be the first start time, right?
Yes, it's going to be the
What
root
if we have
of our tree.
two that are the same?
Like if they're both identical.
Identical.
Well, see, here's the thing. It doesn't really matter if they're the same or not
Okay.
because
Yeah.
we're going to start with the first one and we're going to make that its own tree. And then if the next one, so let's just walk through this real
Yeah,
quick.
we can ask, we can
No,
know if it's identical.
yeah, I think I have this now because what we're going to do is we're going to start with the first one. Now we're going to add every flight that's capable of going after that one to the first one, and anyone that's not, we're going to start a new tree with. You know what I mean? Because so if they're
Right,
if they're
right.
identical, it doesn't matter because identical means they can't go after each other because their start time is before the end time of the previous one. So in this particular example, we would do flight 1 here, flight 2 doesn't go into flight 1, flight 3
So
does,
those
flight
are
4 does.
as an array of nodes. Oh, wait.
Yes.
So those branches are going to be what? Array. So this is array indexes, right? And this is node 1, node 2, node 2 from
Yeah.
the index 0, right? So index 0 of this array has node
Array
or
of
array of,
nodes.
okay.
Yeah, so it would be like 4, and we could even do like flight 5 here, right? And then, because all of these in this thing right here, all of these go after here, but flight 2 doesn't, so it would need to be on its own. And then flight 2, the only one that comes after that is flight 5.
Okay.
And then from there, we would want to go to this array here and see if any of them go, which this would be flight 5, this would be flight 5. So each of these would
Oh,
be.
I don't know if I
Okay,
want to say
and
it's
then
equal or
we'll-
not. Interesting.
And this, right?
Yeah,
After
exactly. So now we need to calculate each of these branches for its max cost. So how would we do that? Because this I think we could put together easily enough. Sort of, because again,
So
Oh,
since
okay.
we already know the indexes of
yeah, so
those, we can just, okay.
yeah, so
right.
like so set like flight 1. It goes to flight 3. Well, yeah, flight 3, and then you'd set. So always, whenever you add a new node, set its. Well, I guess its array is going to be initially null, right? Because we'll have an empty array or array like 0, I guess. But so that's how we can check if there's anything below it. So like we'll start at the tree here, and we'll, loop. I guess either recurse or loop to the next one until we hit a null branch, and then go back at the top. Right. So it'd be like F1, and then be child 0 of F1, and then child 0 of F3 until we hit a null branch.
Okay.
And then once we did that, we'd go up here and go back through again. Because we'd never have to worry about cross branches.
Because it's always going to be.
Yeah, they always have to come after
And
each
it's
other.
always going to be, so the first is always going to be 0. And then those are going to be just 1 plus this.
Yeah.
So index this.
Yeah, so this would be 0, 1, 2, this would be 0, and this would be 0. So we wanna start here, we go to the child 0, and then check every child of that one. And then we check 0, we check 0, and then we check 0 of this one's null, so we go back to this one and check 1. But there is no 1, so that one's null, so you go back to this one and check 1. That one is 1. Wait.
Recursively, you mean, right?
Once it hit null, you want to go back up here and check 1, and then check 0, and then check 1. Okay, yeah.
Oh, so check the previous, from 0 until the count, which is how many times we incremented this branch, for instance.
Well, it would be, so you'd have, your main loop would be this one, and then it would check your 0 of here, and it would check your 0 of here until it got to a null value, and then it would come all the way back up here. Because if null's here, then we know that there is no 1.
Right?
Yeah.
Increment 1.
But we need to go all the way back to, we need to go back to this one. So if this one's null and we've already calculated the max here, then we need to go back here and see if there's a second one here, because there could be a flight 6 or 7 over here that's off 3. So we just want to go back up 1 level and check the next one over here, but that would be null. So we go back here, so we go up 1 level and check 1 here, and then start at 0 again. Oh, like memorize it? Like save what we did before? Yeah. Yeah, we could. But yeah, I feel like this is super complicated.
Wait, if we reach null, which is the array, that's okay.
Yeah.
Then just subtract 1 to go up, and then check if we have other branches.
Yes.
So this is already, is this I equals 0?
Well.
So if we come here, it's already, this is, I'm kind of confused.
Yeah.
So this is I equals 0 for those 2 nodes, which is it?
Yeah. Well, this is so this was node 0 of this one, and this is node 0 of this one. So these aren't. I want to make sure that's clear. So like this would be null. So this would be I of 0 of this one. We'd want to go all the way back up to this one and check I of 1, but there wouldn't be an I of 1. So we want to go back up to this one and check I of 1, and then start at 0 again.
Okay, how are we going to go backwards?
Well, it wouldn't be too hard to go backwards because you would just end the loop at that point, So if we had for loop inside of a for loop, actually, I guess it wouldn't be a for loop because it would be a while. So a while, whatever the flight is not null. You would just recurse. So it would be like, I equals 0. So while flight is not null, you'd start with flight 1's flight would be flight flights, because this would be its node of flights, and this would be I. So
So there's nodes here.
yeah, so when you hit null, shit.
So
So how do we go? See, this is where recursion would really help, because at that point, while it's not null, not null, you would just call. What's it? So you need to go deeper. Shit, I don't know enough about this. Alright, so I think we have the right idea with utilizing the fact that they're sorted. Because we would never have, if we went back to the original idea, because the problem with the original idea is or at least I thought, we wouldn't be able to backtrack, but we don't need to backtrack. Because,
sorted.
yeah, exactly, yeah, so if we did, shit, again, it's still a matter of how deep we're going to go, because the amount of loops is going to be, the limit of how many flights you can do, and we want basically infinite. So we checked this one to each of the other ones, and we found. So we could easily find the winner of 2D. And then we could find the winner of 3D. At least we know the maximum amount of deepness. Because the amount of flights that could be sequential is the number of flights out of the array if they all were capable of being sequential.
Yeah.
So we never have.
But what? So you wanna traverse to the inner the most that you can know, right?
Yeah.
And to know the amount.
Yeah.
And
And be able to check every combination. It seems like it should be a lot easier than making it. Alright. I feel like we've done something like this before.
so, what if we say we just have as an array of values? Okay? So what if we, first of all, this is going to be I equals 0.
Okay.
We're going to go to a loop. So
That would also be I equals 0.
I equals 0 at the beginning. After we know how many flights, okay? So we're going to traverse the array or go through the most that we can go.
But
So
how do you set up the different levels? Like, how do you?
yeah, that's what I'm
Because
saying.
each level is.
At first, we're gonna go to the most that we can go to, okay?
Okay.
To know how many, or what about, so say arrays, is there, I don't know if this is possible, but can we say array 0, so dimensional array of array, right? This is the dimensional array of the index, right? I.
Yes.
So what if we have an if statement before going to this loop, or before leaving this loop, we can have an if statement if I, so array 0, I plus 1 exists. If this exists, then go to there, If it doesn't, then
Hold on one second. We have two things working for us really well right now that I don't think we're taking advantage of. A, they're sorted, so you never have to worry about going backwards. And B, they're all positive integers for money. It's never going to cost us money. So 3 flights of any duration will always be more of 2 of those flights by themselves, right? So flight 1, flight 3, and flight 5 together will always be max compared to any combination of either flight 1,
why?
because you can't have flight
All right.
3 and flight 5 be worth more than flight 1 through 5, because even if 1's 0, which I'm assuming it can't be, and for this project we'll assume it can't. So if we did the max thing, it would really just be a matter of, so we got flight 1, right? So we really just need one loop. So if we looped from flight 1 through the flight array at 0, so flight 1, right, has its own array, and to that array we add every flight that's possible. So we take flight 1, if flight 2 is, we add it, no, we don't, so flight 2 can't, flight 3 we do, and then flight 5 can go after that one, so that's easy, right? Because we can easily go down flight 1, the end time is 5, flight 3, the end time is now 9, and then flight 5 starts at 10, so we know that because the end time is now 9 that we can add flight 5. Flight 1 now has an array of F1, F3, F5, and we know the max for that. So now we know the max of starting with flight 1, right? Now we go over to flight 2 at that point and add everything that's possible. Flight 2, add everything that's possible after that, which would only be flight 5. And we could go to flight 3, but we know everything that could come after flight 3, which is only flight 5, and we don't have to worry about if there's a different combination of flight 3 and something else, because actually,
But it's the same. If we're gonna check for this, we can check for this, right? We can check for flight 3 for this. Also.
yeah, well we could.
But
so,
we can't
so
go
flight,
back
yeah,
with this.
exactly, yeah. So we don't need to start over. So we can, we would just go to flight 1 at that point, which would be flight 2.
But how do you know what is the index of this that has potentially?
Well, we don't care about the index of that, because we would start with an outer loop of flight 0 and then go through every flight below that. So it would be so I would equal 0, and then J would equal 1, and carry on until the end of the flights. And if that flight could go on to flight, because they're always going to be in order. We've already sorted them. We never have to worry about this one being added to flight 1 and then not being able to add. Well,
Yeah.
we don't have to worry about this one being added and then that one not being able to.
Yeah, but okay.
Yeah, so if we did that, we would now have flight 1 would have this array of flight 1, 3, and 5. We could do flight 2. So I guess the only thing.
Yeah, if we sort them, then we don't need to. Then there's no possibility that flight 3 is gonna have something that was originally.
Yeah. So the only thing we have to worry about now is if there was, say, a flight 6, so we would have this with 2 branches at this bottom, and that would cause trouble. But I feel like at that point we would just. Oh, okay. So you do flight 1, and then you grab. So let's say flight 4 can also go after flight 1, right? But you'd never have to worry about 3 being in here. So this would be flight 5, because we can do that, right? We can do 1, 4, and 5, and we can do 1, 3, and 5. So we would have this tree basically. Okay. I feel like we're gaining ground, but I haven't broken through yet. Because that would be easy to just do in loops. And we can easily add that we started with flight 0 and we looped through every other flight, we would know that F3 would go on there, and we would know that F4 would go on there. And then if we went, so flight 1 would be connected to flight 3 and flight 4. Then we know that flight 3 would be connected to flight 5, and flight 4 is also connected to flight 5. So if we added I really thought we were getting somewhere. Yeah, because bringing back the mini tree idea, if we knew that F3 had a mini tree of F5, and we added F3's node, which also carried F5 to F1, then we would be able to get from F1 to F3 to F5. And we can do the same thing with F4. So if we made a node for each flight, and each one of the nodes had every flight that could come after that flight, then we would just be a matter of checking the combinations of nodes and their max value. Let's see what it should be that hard.
I think we're running out of time.
No, it's already 9:20. Yeah.
Do you
We
have,
have a hint.
yeah, do you have any hints over there? What did you come up with?
I'm working on something. I'm implementing the tree.
Okay.
So I'm just implementing the thing that walks it. I recorded all of this if you're interested, but
Right now I feel like we're at the same point that we started at. So.
no.
Every
Like
time
what would the test be that you would write?
Yeah, that's actually a good call. So we wanted to make sure that we had the max. Well, I guess
we don't traverse too much.
yeah. So what are some tests? Because if we want to know the max, it would obviously be greater than or equal to the highest individual flight. So that's something to consider.
What are we supposed to
No. The way you're graded on your time together is that you each basically reflect on your experiences. There's no code. I mean, I'd like you to tell me what your repository was. You didn't create any code. Well, that's fine. I think what's most important, really with the I don't know if it's fine. I might take off a little bit of credit, but because the point is to write code. That's fine. But the most important thing is that you reflect on this experience, working together on this problem, which was kind of tough, and so basically write about it.
Yeah, I feel like it should be a lot easier than we're making it.
It's not.
It's not? Okay, well.
I haven't paid too much attention to what you're doing, but it's.
Unless we have restrictions, right?
Well, and here again, this is a data structures problem. So I don't know what your data structures class was like, but if yours anything like mine, I didn't write any code in my data structures course, which sucked, right? Well, yeah, right. But it's like,
well, 27
but just even did you write it? Did you implement a tree in your data structures course?
I remember doing regular node doubly linked lists in Carla's class.
Yeah. The last time. Not the last
But
time.
that's not a tree.
Yeah, that's the only time
No,
we ever
not
actually
a
coded
tree,
any of that.
actually.
Yeah.
Even
Right.
And 202.
I still only know a red and black tree by looking at it. Not exactly sure why you'd want to use it. But it's the one with the red and black nodes. Alright, well, we have the idea of being able to store a flight with its connecting flights, or the flights that come after it. So we need to be able to write a way to take one flight, check which flights connect to it, and then check the flights that are connected to those. And that seems easy because it seems repetitive. Repetitive is usually not too hard to implement. So if we have a max value, and we got flight 1,
It's actually 9, almost 9:30.
okay,
You need going.
Yeah.
Because it's letting,
I live
right?
really far away.
Yeah, right, absolutely.
yeah, no worries. It
I'm
was
sorry.
fun. No, it's alright. It's fun working with you.
You too.
I'm gonna try to see if I can put something together real quick because I feel like I'm really close. And I feel like it's not that hard. So it goes to flight 2. And then equals the max. So flight 2 goes to flight 5 equals max. Flight 3 goes to flight 5 equals max. Yeah, actually, I like this idea. Yeah, actually, I don't see a downside to this. So instead of doing individual nodes, you just, like we were doing before, you have a max that has a max like node basically that has a value, which is the max, and then an array of flights. And you can, yeah, thanks. So if we take flight 1, add flight 3, add flight 5, the max would be a value with flights. And then we just figure out which max is the biggest. And it would have taken flights. I'll try that.
No, it's doesn't work.
IntelliJ is really cool.
I like it.
Yeah. And I really appreciate you making this music because I probably wouldn't have learned it this well otherwise.
Mm. Okay. Oh, interesting. 19. Or get 19. 19. Oh wait, that might be right.
Yeah, you making some progress?
Yeah, yeah. No, I'm just trying a different test case, and I was surprised by the results, but it's actually right. 7, so it doesn't. But that's not right. So okay, it should be 23, and it got 19 because that one does come after that one. That should be this. Okay, so I need to then recurse. I need to say so. Tree. Okay, add descendants from flight here and add jumped. Okay, so that's where I add all the children. And then I need to say for each tree node, child name is children.
One.
At what point do I end up in an infinite loop? Dude. Okay, well, I think that's it. Can I add another test that will fail? No, well, I won't come back to myself. Even light 6. 11 to 12. $4. Okay, I think I got it.